Thank you for joining me today. My name is Chris Nunciato. I am a web developer in Seattle and mostly a full stack web application developer. And I am today going to be teaching you a little bit about how to use something called Pulumi to build a photo map on AWS. And it's going to be super fun, I think, if I can get it all done in the amount of time that we have today. Things will be great. You can learn a little bit more about me personally on my website, where I mostly just kind of post pictures of my kids and of Lake Washington, and also on the Twitters at cnunciato, if you so choose. I'm also writing this book called Pulumi in Action for Manning. You can find it on the Manning website if you like. The first chapter is free. It is all about how to use Pulumi, mostly to build applications. So it's geared toward full stack web developers primarily, and it's meant to just teach you how to build things with TypeScript and Amazon Web Services and Pulumi, and it's in progress. I'm about a third of the way through it now. I've got a couple chapters that should be hitting pretty soon, and I invite you to take a look. If you like, you can use this discount code, which will get you 40% off of the cover price. So that's cool too. What is this thing called Pulumi? Pulumi is an open source infrastructure as code tool that helps you build and deploy and manage cloud-based applications and infrastructure with general purpose programming languages. What does that mean? Well, that means that you can write programs in Node.js, for example, say with JavaScript or TypeScript, to drive the cloud, to create cloud infrastructure, create applications that run alongside that infrastructure, create cloud native applications of various kinds, and so on. So it's pretty great stuff using languages that you already know and love, which is kind of what makes it really unique. It's cloud agnostic. So in the book, we use Amazon Web Services, but you can use it with Azure or DigitalOcean or Google Cloud or lots of other cloud providers. You can see what the supported ones are on Pulumi's website and such. But yeah, it's pretty great. I happen to actually work on it also, so I'm writing this book, but I also happen to work on the Pulumi project. So that's why you may hear me sort of mention things like we support this and so on. It's just because I also work on the open source project too. Pulumi itself consists of 3 parts. First part is a command line interface, a program that you install on your computer that you will run like in a shell. The second part is a set of language SDKs, which are the programmatic stuff that exposes the cloud to you as an API in the language that you choose. So for example, if you're writing a JavaScript program, you can use libraries from NPM to provision infrastructure on AWS or other clouds using JavaScript, TypeScript. Also supported are Go and Python, C# and F# and the whole sort of .NET family of languages. Other languages are under development also. And the third part of Pulumi is its state management service. And we'll kind of look at what that is in more detail, but you can think of that as just a database or a data store of some kind where Pulumi uses to track the state of your infrastructure and the changes to it over time. If all this infrastructure as code stuff is totally new to you, I super recommend this book, Infrastructure as Code by Keith Morris. It's an excellent book, and it even talks about Pulumi a little bit. You can get it from O'Reilly. It's great stuff, gives you a lot of background on why you should care, first of all, and then what the different sort of methodologies that there are, because there are several. So yeah, I invite you to take a look at that. I think we can probably move on. What are we going to build today? We're going to build a cloud-based serverless web application that shows pictures on a map. You can kind of imagine what that's going to be, like a web page with a map on it and little markers with photographs that we take and upload to AWS and have them show up on this map. It's a thing that I'm kind of surprised we don't see more often on the web, but something that I've always wanted to exist. And so I just kind of, we're going to build it together today. How are we going to do that? We're going to use Pulumi, of course, with Node.js. So we're going to write a TypeScript program that uses Node as its runtime to then communicate with AWS to use the following services. S3, we're going to use to store the images. We're going to use API Gateway to set up a REST API for our web page. We're going to use AWS Lambda to do a little bit of photo processing and also some event handling. We're going to use DynamoDB as a database, which is Amazon's like distributed / serverless key value store. And then for the map, and we're going to use AWS CLI. Actually, you don't have to use the AWS command line tool for Pulumi. It's not required, but I find it's pretty useful, so we'll use it a little bit to debug some things. And then we're also going to use MapBox and Leaflet. MapBox is a mapping service, and you can kind of think of that like Google Maps, but with a really rich and customizable API. And then Leaflet is just a really nice JavaScript library that sits on top of MapBox or can, and makes making the markers and things a little nicer. So we'll do that. Just real quick, let's look at the diagram just so that we kind of really have a sense of what we're gonna make. So the way that this is gonna work is we will upload pictures that contain, say, GPS metadata to Amazon S3. We'll have a Lambda function respond to those uploads and process those photos, pull some data out of them, like GPS data out of them, write that metadata to a DynamoDB table. So that's sort of the first part of the application, how the data gets into the database. And then the second part is we're going to write a web page, which is a single page web app that retrieves data through API Gateway. Oh, I didn't label API Gateway here. That's what that purple thing is. Sorry, that is API Gateway, and it's going to pull data out of DynamoDB for us, and so that we can show it on a web page. So this is sort of, here's how the data goes in, and then to how the data comes out. So hopefully that makes some sense. And a couple of assumptions I'm going to make just so that things are clear. I'm going to kind of assume that you've heard of Pulumi, so I'm not going to kind of give you everything there is to know about Pulumi in this talk. I'm just going to show the using of it. I'm going to assume that you know about what AWS is and what the cloud is, and what kinds of things you can do with the cloud, broadly speaking. I'm going to assume you know your way around JavaScript, TypeScript, and Node.js. That you can write programs in JavaScript that run in Node, and you won't be completely lost when it comes to that. And that you kind of know a little bit about full stack web development, that the stuff that I've described up to now, particularly in the diagram I just showed, isn't completely confusing to you. If you know how to build web pages that make asynchronous calls to REST APIs, and you know how to pull data out of databases and show it on web pages, you're going to do fine. So those are the assumptions that I'm going to make. Okay. All right. So I think we can probably get started. So I'm going to switch to the code view now. Okay. Cool. Actually, I think I'm just going to go to the code only view here. All right. We're in Visual Studio Code here, and I'm going to open up a little terminal tab here. And we're just going to start. So I've installed Pulumi, and I have Pulumi version 2.12.1 with Node 12, that. And the AWS CLI version I'm using is 2. Just so you can get some sense of like what I've got going here. What's the first thing we're going to do? I should also mention that I have environment variables that are set locally for AWS configured, essentially. My AWS client is configured in the standard way. So I have some environment variables, AWS access key ID equals something. And then I also have an AWS secret access key value set as something else. Those are 2 environment variables that I've got set, and that is so that Pulumi can communicate with AWS on my behalf. So Pulumi communicates directly with AWS. Its libraries just know how to do that. So those are two environment variables that I happen to already have set. I think that's it. All right. So here we go. We're going to use Pulumi new AWS TypeScript. And so this will create a new project for us from a template That's just a little bit of code that'll help us get started. So we'll take the default name photo map, which it has recognized from my current directory name, folder name, which is empty, by the way. And a photo mapping thing. Okay. And then it's going to ask me for a desired stack name. So a stack is just a collection of cloud resources. So you can think of a stack as like kind of like analogous to an environment. So we're working in the dev environment here. So by default, Pulumi is giving us the name dev for our stack. If we wanted to deploy into other environments, we might have more stacks, say a staging stack or a production stack and so on. Right now we're just kind of in dev land, so we're just going to kind of accept the default name of dev. And for the region, I'm going to pick US West 2 because I'm in the Northwest. You could pick any region here that is, has the resources available that you want to use. So right now, Pulumi is installing all of the Node.js SDKs that we're going to be using. And here that seems to have gone okay. So now let's look and see what we've got here. Okay. So we have some new files. The first file we'll look at is this project file. This is just some metadata about the project that we've created. We're going to be using Node.js as a runtime. This is the name. Here's the description that I entered. A stack configuration file. So for the dev environment, we've configured that we want to use US West 2 as the region to deploy into. Package.json has the dependencies that we installed. So these are the libraries that we're going to use that use for provisioning and managing cloud resources and for running Pulumi itself. And then we have a program. And here's our basic bare bones program. This program happens to define an AWS S3 bucket. And that's great because we're actually going to use a bucket for uploading our pictures. So if you noticed, the program output said that we can run a Pulumi up to run an initial deployment. So let's just do that. I'll win back a little space here. So I'm running Pulumi now to go and create my bucket. And what happened here is it previewed for me first to just say, hey, this is what you're about to create. Do you want to go and do that? Yep, I do. We'll do that. And this takes a little bit longer because I'm running all this video stuff, but it usually takes under 10 seconds or so. Cool, so we have a bucket, and you can see the bucket was named my-bucket and then some extra stuff on here. This is called auto naming. I won't go into it too much, but essentially this is here to make it a lot easier for you to write programs that can run in many environments without having to fiddle around with trying to name everything uniquely yourself. There are many other benefits. It's called auto naming. You can read about it in the Pulumi docs. This may irritate some folks. I know it did me at first, but I promise you this is so worth it and makes life a lot easier. At any rate, we have a new bucket that we've created. See, this outputs here is also another thing to pay attention to, is that we created the bucket and then we're saying export const bucket name as bucket.id. And this is what's called a stack output. And this is helpful, and we'll see another sort of more helpful use of it later, but we can, as part of the stack when this runs, we can actually export or emit values that can be consumed by other projects and stuff too. So just a brief note about what that is all. We'll spend more time with it as we go. But this guy here, this declaration. So as I mentioned earlier, Pulumi is a desired state tool. I don't know if I did mention that actually. Did I mention that? But the way that Pulumi works is you write a program, and in that program you declare cloud resources, and Pulumi receives those declarations and notes that you want to have those resources created. So what actually happened here was that we didn't create a new bucket with this statement. What we did was we declared a new bucket, and the act of declaring that bucket instructed Pulumi of our desire to have a bucket exist as part of this program. It's a subtle difference, but as you'll see, we can run this program again, and Pulumi will not actually go and create another bucket, because it will recognize that the bucket that we want to exist already exists. So nothing's going to change here. We can run this update. Apologize for the wrapping and stuff here. This is just because the type is so large. And we can see that nothing changed. So our desired state has been achieved, and that's great. So yeah, cool. We can also customize these resources. So I want to add a couple properties here. What do I want to do? What do I want to do here? Okay, first thing I want to do on my bucket that I upload files to is I want to make sure that people can read them, that they can be read like from a web browser. So I'm going to set an access control property of public read, which basically just tells AWS, hey, let the public internet read what the images are that are uploaded to this bucket. And I'm also going to add force destroy, which is useful because when we go to tear this infrastructure down later, there's going to be some stuff in it, images. And if we don't do this, Pulumi will not destroy the bucket. Instead, AWS will actually complain that there is stuff in this bucket, you can't destroy it. And so this is just saying, no, really, when I say that I want to destroy a bucket, I want you to also delete all the data that's in that bucket too. Yeah, so there we go. So let's run Pulumi up again and just apply these changes to that bucket so we can see kind of what that looks like. Again, we're going to run that preview step first. And then in doing that, it'll tell us that, hey, we're about to update the my bucket. And some of the details there are here. We're changing the access control from private to public read. And then we're changing the force destroy property, which is default to false, to true. So let's just say yes, and we'll apply these updates. And I think now, once this finishes, this should take about another 10 seconds or so, but 14 because of CPUs and stuff. Yeah, so that's good there. So now we have a bucket. Now, great, we have a bucket. We can put things in it. I think AWS S3 ls S3:/ my bucket. I'm gonna read what's in that bucket. Currently nothing, I think. Yeah, just nothing at all. Another thing you can do, you can execute Pulumi stack output bucket name, and that will programmatically retrieve that value from the stack export. So if I were to say Pulumi stack output all of the things that are outputs of this particular stack, you can see only one is listed here, and that is the bucket that we have created as part of the stack. So I'm just going to march ahead here, but we've got a bucket. We can ask for its contents with the AWS CLI if we want to. It doesn't have anything in it yet. And so now what we're going to do is wire up some interesting stuff. So did you know that you can, with AWS, you can attach event handlers to interesting events that happen within the AWS cloud. One of which is when a file is uploaded into a bucket, you can write a function that responds to that upload event. Pretty cool. I didn't actually know this when I started working on Pulumi, believe it or not. This was totally new to me, and I think this is one of the coolest things ever. So let's wire up a little function here to respond to bucket uploads. So let's see, where is this? Okay. Bucket.on, it's on object created is the event. This is actually a function call that will wire this up for us. Upload handler, we'll say event This should look pretty familiar to you if you're a JavaScript developer. And let's see here. Let's just say, you know what? I'm just going to say console.log event, just because I'm lazy. And I want to see what happens here. So what is this all about? First of all, let's run Pulumi up to apply this change. And essentially, we're creating a bucket handler and a function to run in response to bucket uploads when bucket objects are created. And when that happens, I'm going to log out the contents of that event. So we'll apply this change. What's actually happening here, if you didn't happen to notice, was that Pulumi, in my declaration of that function, or as a result of my declaration of that function, is creating a bunch of stuff for me on AWS that it needs in order to wire things up in the way that my program has expressed. So my program has said, when someone uploads something, I want you to run this function, which will eventually become a Lambda function. That function was created by Pulumi, as you can see here, and also the sort of AWS identity and access management policies and things that are required to make that work were also created implicitly by Pulumi, because Pulumi just recognized I would need those in order to have things work in the way that I've expressed. So that's kind of cool. One other thing that you may not have noticed is that there's a link here that takes me to the Pulumi console. So we're going to go and look at that. So in the console, this is the dev stack that I've just been creating. You can see that the activity of the update that just took place is shown here. We can look at a log of the actual differences that took place in that update. The full list of updates is here, and the list of resources that Pulumi is currently managing for me are all listed here as well. So this is what's called the Pulumi console. It is the default state management backend. I'm using it just with my personal account here, which everyone can use for free. It's sort of unlimited in that sense. You can create as many stacks as you like for free, and Pulumi will track all their state for you automatically. But the console is a good thing to know is around, and we'll come back to it here and there as we go. So that's a good thing to be aware of. Back to the code. Now let's do something interesting. Let's do this. First thing we'll do is run Pulumi logs. So it's collecting the logs for stack dev since about an hour ago. And there aren't any because nothing has really happened in this stack yet. But what we can do is follow those logs, and we'll just kind of let this run. What's actually happening here, I'll talk about in a second. The next thing that we'll do is we'll upload a picture, say, CP from my desktop, photos, I think it's kawaii.jpg, to s3:// and then let's just use our Pulumi stack output bucket name. And we're just gonna, so what we're saying here, I apologize for this squunchiness of this, but we're copying a file from desktop photos kawaii.jpg. I'm just gonna verify that that is actually the right file name, photos kawaii.jpg, yes. And we're uploading it to the bucket that we just created. So let's do that. That should work. You can see it's going there. Cool. And now over here, if we watch the log, we should see something interesting happen here because we have uploaded an object. We have an object, an on-object created event. Oh, look at that. So now we have the event that happened, and here is the event metadata. So this is all the stuff that comprises the metadata object that we get back about that, that event. Pretty cool. So what do we want to do though? We want to actually do something with this. We want to do some more here. We actually want to put this, I'm going to leave the log statement there, but what we're going to want to do is put these images or their metadata into a database. So we're going to have to create a database for that. So let's do that. Handle uploads, okay. Create a dynamodb table for our images. Cool. All right, so what is that thing? So I invite you to take a look at dynamodb and what it is, but you can basically think of it as just a key value store. And so we're going to store images with keyed in a certain way, so given a certain kind of ID, and AWS takes care of all of the storage of that. It is a serverless database, so there's no cost to using it except through actual use. So whereas the cost of like a more relational database like MySQL or Postgres or something, which is sort of running all the time, DynamoDB is not running all the time. It's just you just pay for the number of transactions that you make. It's a bit more complicated than that, but used at a very small level, which is what we're going to be doing today, it's essentially free. So let's just make a table for storing these images. We'll say const table equals, and then similarly new aws.dynamodb.table. And we'll give the table a name. We'll just call it images. And the properties of this table, it has certain requirements. So if you see the squiggles here, it's telling me, hey, you're missing some things like attributes and hash key, which are required things. So the attributes that we need our records to contain are a name property, or sorry, a created property, which is actually it's a date, but DynamoDB stores it as a number. So we're going to give each image a date, essentially a timestamp, and then hash key is the way that the data is indexed in DynamoDB of created. And then also we need to give it a billing mode, and this is sort of esoteric, but you have to tell DynamoDB how you're going to pay for it. And the default is not pay per request, it's something else. So we'll just specify this. Essentially, this just means, hey, we want to have you, store our data in this particular way, and we're going to use the pay per request plan for configuring it. I'm going to Control-C the tailing of the logs, and I'm going to run another Pulumi up. This time, I'm going to skip the preview portion and just make the thing to save a little time, because you can do that. So we're running Pulumi now to go out and provision, to go out and create that DynamoDB table. Usually this is pretty quick too, on the order of 10 or 20 seconds. But again, because CPUs and video cameras and things, it's a little bit slower. Great, okay. I don't know though what the name of that table was. So why don't we so in the same way that it created a bucket for me earlier and exported my bucket name, I would also like to know what the table name is for this table. So I'm going to make a change here, and I'm going to also say, export the name of our resources. I'm just going to make this more abstract. Export const table name equals table.name. And notice how I haven't really called this out, but because we're using a language, hey, we get like the full surface area of AWS in code hinting. So that's pretty cool. Okay, Pulumi up. Again, we'll just skip the preview. We're not actually changing any infrastructure here. We're just adding a value that AWS has already produced for us and exposing it back to ourselves so that we can use it. So our table is named images dash, and then our auto named unique identifier 2. So in the same way, I think we can say AWS dynamodb, just to see if there's anything in there, .scan table, and I've got an older one here, but we'll say, I'll just paste this in here rather than type it all out. Items of none. Okay, so table is empty as of now. Let's do something about that. Okay. Next thing we want to do is upload some metadata. So here we go. The event is going to have certain properties on it, and so you'll see what those are as we go here. So we're going to pull that out. Oh, what's it complaining about? Is it going to say that it's maybe undefined? Oh, let's see. Yeah, I think it might not have a value on it. So if there isn't any records, something's gone wrong. So let's just not return. Okay, that's what it was. So it was just complaining that the value might not be present. It's TypeScript trying to protect me there. We're going to need the ID of the uploaded object. Or sorry, no, the ID of the source bucket, my bad. Okay. And then const object key record dot s3 dot object dot key. Yeah. So this is the identifier, the path, essentially the path and the name of the file that was uploaded. So again, we're retrieving the event, parsing it out, pulling little bits of information out of it, namely the bucket that it corresponds with and the path to the image within that bucket. Those are 2 bits of information that we've got. So next thing we're going to do is go and fetch the image as a binary blob. So here for this, we can use the AWS SDK for JavaScript, which Pulumi actually ships for us. So if you've used the AWS SDK before, in other JavaScript contexts, you can use it just as easily here as well. So what are we going to do here? We're going to await s3.get object. Nope. Get object, and we're going to need to pass that some stuff. What stuff? Bucket, and this is going to be bucket ID, right? Bucket ID, yeah. And then the key is the object key. Oh, you know what? I think I have to mark this as an async function. That's right. I'm assuming you kind of know what I'm doing here. So the AWS SDK is promise-based, and so we're gonna want to use. We don't have to use async await. I just sort of prefer to, but yeah, that's what that's all about. And to use that promise-based API, we'll just call dot promise on that retrieval. Okay, so cool. But you know what? I just realized that. So now the next thing that we're gonna want to do is extract some data. To do that, the specific data that we want is exif data. Exif data is the metadata that you see in JPEG images sometimes, so the creation date and the source camera and all that stuff. Also the GPS coordinates. That stuff is all stored as exif data inside a JPEG image. So we can do this because we can use a JavaScript library to extract that data for us. So let's do that. And I think it's called exif parser. Let me check my notes here. I think that's what it's called. Exif parser. Yep, that's it. All right, we're gonna install exif parser as a library that we want to use. And you can see that it was added as a dependency to the project. Cool. And so we can import exif parser. I think, anyway, is that how this works? I think that's how we do it. Extract some exif data. Parser. I think I need parser. There we go. Constant. Okay, yeah. Okay, I gotta import it here. Parser equals require exif parser. Okay, so we pull in exif parser as a dependency, and we use it. Parser dot. Oh, I don't think I have any completion here. Sigh. That's okay. I made a couple of notes. Parser dot create, and did I call that? Yeah. Buffer dot body dot parse. Okay, so this is the extracted exif metadata as a JavaScript object that comes out of that JPEG. Okay, so the next thing that we're going to have to do now that we have the exif data, so we have the image, we have the exif data that's come out of that image that we've extracted from the buffer, the binary data of the image, and is that we will create create an object or some metadata, the metadata for the object, for the image, to store in DynamoDB. So we're going to create a JavaScript object that contains that data. So that is going to just be a simple JavaScript object of some kind. So I'm going to give it two properties, S3, which is the S3 data that distinguishes this particular image that we've uploaded. So I'm going to tell it what the bucket is for the image, the key for the image, and also the URL where the image is going to be located. So this is going to be a string, and it'll be comprised of like a long AWS URL that eventually is the URL to the image in the bucket, publicly accessible, as we did before. Bucket ID, and then this is just AWS's way of naming these URLs. Oh, you know what? I don't think I did this part. Yeah. Region. Okay. I'm going to just hard code this as US West 2. Cheating a little bit. The truth is, if I wanted, maybe I'll show you how to do this at the end, but I can read this value. I can actually read this value in the Pulumi program from the configuration, but I'm just going to roll ahead for now, just for time. Amazon AWS.com / and then the key, which should represent the URL to the image. Okay, cool. And the second property that we're going to use is, oh my bad, the GPS coordinates. Latitude, which is exif.tags.gps latitude, and the longitude, exif.tags.gps longitude. Okay, so this is the object data, the metadata that goes along with the image as we retrieved it from the event, remember, from the upload. And we're going to store this stuff in DynamoDB. So this is the thing that we're going to store in DynamoDB. Last step, write the record to DynamoDB. And just so that you can, to refresh your memory, we're uploading to the S3 bucket. We're literally writing this Lambda function right now, this callback handler, which is storing this data into this table. So soon we're going to be done with this part. Okay. So similarly, we're going to make another, we're going to use the AWS SDK to write to that table. Const client equals new aws.sdk.dynamodb.document client. That's the thing that we're going to use for DynamoDB. And notice, like you similarly to before, you got the whole like AWS surface area that you have access to by way of the typings that come along with the AWS SDK for JavaScript, which is super cool. I use that all the time. Await client.put, and we're going to put the record that we just created. We got to tell it where we want to put it though. So we want to put it in the table name of the table that we defined earlier. This table name is a reference to the table that we just created. You can see up above there, that's the DynamoDB table that we just created. And the item that we want to write to the DynamoDB table as a record consists of this data. We're going to say new date dot get time. I think I could have done date dot now, but I never remember to do that. And then just image. Image, I could also say, of course, image, but that's just redundant. I'm just going to be cool and modern and just use that notation instead. Okay, so theoretically, if I haven't screwed something up, I should be able to run this code to update the Lambda function that I mentioned over here to do the writing of this upload event to DynamoDB. So I'm just going to review my code really quick here to make sure that I haven't missed anything. Fetch the image. Okay, so I have the image as a buffer here. Pull some data out of the image, exif.parser.create. That seems like it's probably okay. Create the metadata for the image. So I've got this. I kind of cheated a little bit here. I said that we could read this value if we wanted to directly from here. If there's time at the end, I'll come back and show you how to do that. But yeah, that is as it is for right now. And then exif.tags. Let's just check my notes and make sure that this is right here. exif.tags.gps latitude and GPS longitude. Exif. I think that's okay. And syntactically, we seem to be fine. So TypeScript seems to be okay with that. Is something being compliant? Oh, bucket ID. I missed that. Bucket ID. Ah, there it is. And then table name, using the table name. And we call .get. This is called a runtime function, and it's we don't have enough time to go into it really, but essentially this collectively just lets me use a reference to the table that was created as a variable. It's just a programmatic facility that Pulumi gives us access to. I think it's time to run this thing, so let's do it. So we're updating that Lambda function to handle the image uploads. And it should be telling me that it's going to update the function. So it is. That looks fine. Yay. Let's do it. And to be honest, this was really the bulk of the work. Like everything else from here on out is pretty straightforward and simple, but you know, I'll leave that to you to decide, I suppose. But this was the meaty part of the demonstration, I think. Cool, so that happened. That seems to have worked. So I am feeling like I think what we can do is let's do some logs again. So let's tail the logs once more. And again, specifically what's happening when we tail the logs, I don't know if I explained this, is that we're asking AWS CloudWatch to give us the logs for this particular stack. When interesting things happen in AWS, you can have the logs for those interesting things sent to CloudWatch, a service provided by AWS, and Pulumi is able to kind of collect all those up and expose it to us as an output stream. So this is actually a under-discussed but very awesome feature of Pulumi that I use all the time, as you can see. So I'm watching the logs now, and I'm going to upload that same image again, since I know that works. and theoretically, we should see another event occur here. Let's just give ourselves some space here. I'll clear out the buffer. Okay, I think this happened unless there was an error. I guess I didn't log anything to tell myself that it actually succeeded. Let's just run the query from dynamodb to see if we have any records in the database. None, of course. So here's what we're going to have to do. We're going to have to figure out what went wrong there. Something must have gone wrong. Oh, you know what? I didn't say that I wanted to await the promise. So let's try that. And also, I'm just going to say -- yes so that I don't have to approve it and save more of your valuable time. Okay, so let's tail the logs again. I'll just clear the buffer out and upload a file again. So the upload succeeded. We should get another event notification here in a moment. Okay. Let's see if we have any stuff in our table. Aha! Look at that. We got things. Lovely. So we have one record with a create date of just a bit ago. And you can see there's the key. Here's the bucket. With any luck, I can click this thing and get to it. Let's see. I'll do that in a minute. And then you can see the GPS lat and long is there too. So here's a bummer though. With the large browser, you can see it clearly. I have failed to provide access to the image which I have uploaded. Do you know why? Now I know why. It just occurred to me. Here we go. Because the reason is because when you upload a file with the CLI, you have to say also ACL of public read. So I'll be honest and say that when I usually do this, I actually do it with I do it with my phone, like with an S3 client in my phone or on my Mac, and I'll just drag files to that thing, and that thing sets the access control to public read automatically. So I often forget this step, but theoretically that should work, and indeed it does. So I can reload the picture, and I'm not sure what the heck happened there. Did I screw up my layout or something? Guess I did. Yeah, sorry about that. All right, I fixed that, I think. Cool, so that is set. So now we have the image uploaded and accessible. We have records flowing into the table. I could show another one, but I'll just wait to do that until later. So cool, let's go back to the code then. Where are we now? Okay, the next thing that we need to do, what do we have to do next here? We have the records getting written, we have exif parser running, that's all lovely. I guess the last bit is we need to figure out how we're going to pull these records out of the database. So this is going just fine. I think we're going to be okay here. So we're going to use a thing called AWS API Gateway. So I'll go back to the diagram and say, okay, here's API. So the data's in the database now. API Gateway we'll use to pull the data out of the database. So we're going to work on this bit right now first. So the first thing that we're going to do there is create an instance of AWS API Gateway, and that will be fine. So I'm going to close this out. Okay, so const API equals new AWS x dot API gateway dot API. No. There we go. API. And the properties that I want to pass to customize that API instance are going to consist of one property mostly, which is an array of routes, one of which will be the path of /markers, and that will be a GET request, and we will say event handler, which is going to be another function, which also will actually be serialized as a Lambda function, similarly to the event handler that we just built. And here, the handler that we write just needs to return a status code and a body. That's the interface that we agree to abide by. Here, though, what are we going to do? We're going to fetch some data. Okay. And by the way, I'm going to put all this code up on GitHub so you can get access to it if you want to look at it. Const client equals new AWS dot SDK dot dynamodb dot document client again, similarly to before. We're going to say const items equals await client dot scan. And so scan is the command that we use to essentially, it's like a select star from DynamoDB, this particular table. And then we need to identify that table. Table name of table.name.get, which will reference, again, we can reference programmatically by the table that we created above, table name. And then this is what's kind of strange, the projection expression, which is essentially oddly named, but it is just the columns basically that we want back, the fields that we want back in the results set. Okay. So now that is going to say, give me all of the, thank you, typo, spell checker to the rescue. And then we're going to return the records as a JSON array. Cool. Return. I said before we have to set a status code, so we're just saying all's well, 200 okay. And then body of a string representation actually of the items that comprise the result set. And I think that is going to be it for the gateway, at least for this portion of the gateway. So again, we'll say Pulumi up, skip preview yes. I'm being a little sort of shorthanded just because I want to conserve time. We could go through the preview step again and everything, and that'd be fine, but I'm just trying to save a little bit of time. So we're creating here a new API gateway instance in in AWS, a Lambda function, which is the function that we defined here. So Pulumi is serializing this function and uploading it to AWS Lambda for us, so we don't have to do any business of like creating it somewhere else and then wiring it up and stuff. It's just we can express it right in one program, and then and that. What happened there? Yikes! I hate it when it does this. It's probably gonna leave me right there. Okay, cool. Good. And so it created the REST API. The appropriate permissions and policies and things in AWS to make this all work. And again, if I want, I can look at all of this stuff, this particular event also in the Pulumi console, and get details about the diffs and everything that took place in that update as well. So that's cool. So now, in theory, we should, but one of the things that AWS does when it creates a gateway is it assigns a URL to that gateway dynamically. And I don't know what that is, so I need to know what that is. So I will export it. And let's see. API URL, API dot, and that's the URL property. Okay. And I just only added an output there. So it should just be telling me, hey, here is the dynamically generated API URL that AWS assigned to the gateway that you just created. And so a gateway being, of course, a REST API. Okay, good. So now back to the diagram. We now have more of this fleshed out. And so we should be able to actually maybe curl this API URL slash markers, I believe, right? I can type it to JQ to make it look a little bit nicer. And there they are. So a couple, looks like I've uploaded it a couple of times. Yeah, there are a couple dupes in there. So don't judge me. But that is what I want it to be. So that's great. So we're making some good progress here. Now what? So now we've got the I guess the last little thing we need to do is we need our web page, don't we? So we need a web page. Let's do this. I'm going to make a folder and I'm going to call it www and a file of index.html. Okay. And I like my HTML5 helper here, which kind of defines a bare bones HTML page for me. Okay, so this is a file called index.html. What I want to do, what I can do with Pulumi also is tell API Gateway to serve up this web page for me automatically. So let's do that. I'll go back over here and we'll add another path to API Gateway to define a URL that we can serve the web page from. So we'll just make this one slash, just the root, and the local path of www. Okay, so now in here, I'm gonna go over here and say hello. And I'll run another Pulumi up. And so what will be happening here is I'll be defining a new route for the API gateway, and then we will be uploading the content that we want to create. It's a little mashed in here, unfortunately, so you can't quite see it, but we're creating another bucket, another bucket object, and then the appropriate access policies and things for this to be made possible. And so we'll just proceed with that. And I think now we should be able to browse to the web page. Let's see. Wait. Okay, hold on. I think if we click this, yeah, okay, cool. There's the web page that we just made, so that's great. So now the last bit, and let me see how we're doing on time. We're at 50 minutes, so I'm gonna take a little bit of a shortcut here. I'm going to go and take my index.html file, which I already baked in my Easy Bake oven, and I'm gonna paste it over here in my code window as a finished product. And I don't want you to be too sad about this. It's really just in the interest of time. But here's what I'm gonna say, okay? What this web page does is it adds Leaflet, which is the overlay to MapBox, which I described earlier, and I'll just open up a browser so you can see what that is. So Leaflet is a really nice JavaScript library that, as you can see, I kind of included here, and I just included it by CDN using unpackage, which is just publicly available repository for useful JavaScripty things. And Leaflet is just fantastic. And what I can do is provide Leaflet with my public API key for MapBox, which I've obtained from MapBox. You can do this also. Just go to mapbox.com, create an account, and a free account. You will get a public token, which you can use to for various purposes. I don't want to go too deeply into MapBox, except to say it's a good source for maps. And so here's my public API key that MapBox has provided to me to make maps with. And I'll just walk through the code briefly here so you can see what's going on. Since as I said before, I'm assuming you kind of know a little bit about web development. We're adding a listener when the document loads. I'm setting a constant value with my API key, which I just got from MapBox. I'm initializing a new map with the ID of the element that will contain the map. So there is a div in the web page down here with an ID of map. The map will go into that page. I'm going to center on where I am right now. So I'm going to, I may have to actually approve this, but and this isn't necessarily required, but I'm just asking the web browser what my current geolocation is, so that I can position the map as opposed to looking at the whole Earth, just kind of where I'm located, and setting the map view using Leaflet on that view. And then I'm gonna go and make a request to my my settings endpoint. I call it ./settings just because the web page itself will have been served from that same URL. So I'm calling the settings endpoint and pulling the settings into an object. I'm fetching the map markers at the markers endpoint, which we curled earlier. And then I'm just making a marker, a clickable marker using the Leaflet API. Again, all really well documented here, but it's basically going to be a thing that looks kind of just like this. And I'm adding that to the map instance that I declared up above here. So for every marker that I get back, I'm going to create a marker on my my web page for it. And then I'm just going to create the map using a certain set of tiles that that MapBox makes available. And again, I'll put all this code up on GitHub so that you can look at it. But essentially, I'm saying, like, make me a MapBox of this type, and here is my API key. And so, and that's it. That is and I'm saying, make the map consist of the entire browser height. So I'm just going to say, let's go ahead and run this thing and see what happens. Give myself a little bit of room here. I Okay, I'm going to say no because there's too much noise in the UI there. Here we go. Oh, I just realized that, did I just cover that whole thing up? I hope I didn't do that. I think I did. Well, let's go back and look at this. I think I did. Okay, I think I covered that up. That was a blunder. That makes me sad. I may go back and edit that. So I'm going to allow myself to do that. But okay, let's see if this works. Yes, we're going to do the update. And as we run this update, we're now updating the changes that we just made and deploying them to the bucket, which will be served by the API gateway. Okay, so now what we can do is go back to the browser and reload this view, and it's going to ask me if I want to allow for my location to be, you probably can't see that, I think. Yeah, it's just hidden. It's a native thing, but it's asking me for my location to confirm it. I will say yes. And I'm not seeing anything. I wonder if I'm going to get an error here of some kind. Uncaught. What happened? Did I get an error of some sort? Oh, settings isn't there. Of course not. I don't actually have, I'm not making that call. That's right. I trimmed this back because I didn't need settings. Again, let me go back here to code. So I actually didn't need a portion of the file that I had pre-baked. So let's just update again with without that unnecessary bit. Okay, so that should have fixed at least that JavaScript error. So let's go back to the browser now and see if we can enjoy the fruits of our labors with that. Aha, there's a map. You don't see anything on this map though, I think because the picture I took is in Hawaii. So we're going to go over here to Hawaii. Just kind of a little bit out of the way here. Haha, there it is. Look at my marker right there. If I click this, do I see the picture? Yeah, yay, it worked. So let's do another one. So I'm gonna upload a picture. Let me see what pictures I have, something that's a little more normal. Let's say I'll upload me and the kids and everybody there. Let's see if that works. Super noisy. Sorry about the overlap. I'm just uploading a picture there to the same location. And now we'll go back to the browser. And I think if I reload, this may take a refresh or two. Oh no, there we are. Okay, cool. So this is up in Edmonds. So I'm located kind of right off of Lake Washington here. Here we are in Edmonds. And that's us with our masks on because life. So friends, I think that kind of does it. Again, I will totally take all of this code and put it up on GitHub for you. But what did we just see? Let's go back to the diagram. So we built a workflow with Pulumi that handles uploading uploaded objects to Amazon S3. and processes them with AWS Lambda, writes their records to a DynamoDB table on AWS, retrieves them with AWS API Gateway, and pulls them and shows them on a web page using HTML and JavaScript. So again, I'm going to come back and make sure that this code is all well commented so that you can refer to it if you like. But I think that is it. If you have any questions, you can totally find me on the Twitters or on GitHub. And this is incidentally where I'll upload these examples so you can refer to them later. Once again, please take a look at the book. I hope you like it. And again, don't forget to use this discount code if you so choose. Thank you so much for your time. I hope I didn't go too fast. If you have any questions or feedback, please just feel free to reach out anytime. You will find me in the Pulumi community Slack. You can definitely find me there, or just on Twitter. Take care. Thank you.